Oh, sorry. Please introduce yourself.
Okay, hi. I'm good afternoon. I'm Haiwei Xue, a graduate student from Tsinghua University in China, so as the speaker for this report sharing. My partner Sicheng Yang and I are the first authors in this work. We are very interested in the code speech gesture generations. After all, the novel verbal gestures are the very important part of the AV communications. So, okay, so we have some so we have the same goals, that is to generate some more humanized and more appropriate for the video, audio, and more diversions code speech generations, code speech gestures by considering audio text and body movements of the both sides. And this test is very interesting and novel, but it has some problems. First, and how can we model learn the varieties or to generate the different gestures to make it seem more humanized? And second, how to make the generate gestures and speak have a highly degree of the matchings for the audio. And unlike early years, the listener BVH motions information is also included in this test. So how can it be taken into the account, right? There have been several approaches to solve these problems in the past, but there is still some problems in there. For example, we immediately think about the game-based approach. It can generate amazing pictures and what you will need, but its training is so difficult, and it is difficult to get the novel loss chorus. And for the VAE-based methods, we consider diversities by in the quality. And for Tektron-based methods, it gives a better audio matching, but maybe the humanized need to be improved. Okay, so therefore, we have done the following work in this challenge test. First, we propose the DiffuseStyleGesture architectures, multimodal driving gestures generations modeled with the improved input network structures and input modalities and the future representations, and as well as the diffusion models with the local attention. And secondly, the emotions of the GENEA challenges shows that the generated gestures of our models are humanized and the speech matches. First, we discussed the different diversities of the generated gestures, as well as further discussions for more technology details. Right. Okay. In this challenge test, our pipeline is that we first observe the data and try the baseline, and we found that the audio matching the degrees was quite good in the Tektron-2 based approach. And we then look into the related world papers to find, but we found that there are still very few papers on two-person interactions gestures. So it may be a novel and a valuable research topic. So since we already have some early work on gesture generations published in the IJCAT 2023 diffusion data gestures, so we modify it into this test for next experience and the paper rating. Right. First, in the dataset analyzed, we found that the overall the data is about 20 hours. We found that the data's duration was unevenly distributed, with some data lasting over the 500 seconds. It made context-rich context semantics, which can input the models to training effects. While the averages, the diversions of the data in these test data sets and the validation data set is about 1 minute. So we finally, our training windows choose the 5 seconds to achieve a better training effect. Okay. And in the test modalities, the test data sets and the validated data set should contain no more than 200 words. In particular, after we conduct the word frequencies statistics, we found that the 3 words are very high using. It's about like, I, and yeah, right. So we believe it is not only laughter should be considered. Maybe some words such as the year, maybe should be taken into the account. Yeah, right. Okay. And in BBH, the fields, we found some issues with the data sets. In the BBH fields, we found some data, maybe upper bodies of the most humans are figured out, and some especially some data, maybe some speaker have no unnecessary data foot, right? And some data and some data sets also contain the survey the bound errors. Okay, and next, after analyze of data EDA, let's talk about our final solutions. Our solutions is based on the diffusion style gestures. The send author is mine in these papers. Recent diffusion-based speech-driving gesture generation approach. Besides these gestures, audios, and speak idea, we also take texture as the additional input modalities. We use total 6 modalities, including speak idea, and 10 state and 6 gestures, audios, text, and the noise gesture. In fact, we can use the features of the both sides to concat here, but due to the imitation, the GPU of our task, so we get off the feature of the 2 people. So we only use the feature of the 1 person in order to make the model to train more epoch, right? So then with the feature extraction and the dimension transformations of these 6 modalities are carried out and concat the result tensor and fit into the cost attention the modular and use the self-attention to do the context information enhancement, and finally after the results. And the whole diffusion models learned how to denoise the gesture data with noise, and learns the minimize the loss functions through the hardware loss, right? Okay, this is our experiment settings. For when we use the 1.2 minutes epochs, the model got a good performance. And our methods got the first tag in the assessment, the second for human lives, and the third for the appropriate main agent, and the fifth is on the interpreter. Okay, and this is our following some examples of our output the demo of our models. Our diffusion models can extract semantic information and generate the human-like gesture. We found, for example, when speakers say a large, for example,
photo, and when we show the photo to photo, and
so
when we show the photo to some, they're really surprised how we forced that we said we didn't force her. She had also a lot of responsibility.
Yes, when say large the models generate the large gestures, and for example, when say
we got a bit.
Where do you stay at?
It always
when speaker asked, what do you say? Our model generated a pointing gestures, right? And maybe when laughing,
Great for me, but other
body
people
shake and miss human laughter.
that goes well with the.
Yeah.
And 5 minutes, we found the thinking has some thinking the actions, right? Okay. Okay, in the generals, we based on the diffusion state gesture framework, we add test modalities and more logically decide as the input architecture of the modalities. So in the future, so we can consider the gesture and speech information of 2 persons and add more conditional information. Okay, that's all. Thank you. Thank you for attention.